Welcome back to our class on textile finishing. Let us see what did we do last time. We talked about anti-stat finishes, and what did we learn? We learned that fibers can accumulate static charge. Static charge, if accumulated, is definitely harmful. There is a process by which the charge can be dissipated, the decay can be measured. The strategies we tried to understand how to make anti-static textiles. We also learned that anti-static finishing, like for example soil release, like from example softening, they are all surface finishing treatments. They basically demand surfaces to be changed. We did learn about chemistry of some of the anti-static agents, and very interestingly we found that saponification can develop durable anti-static synthetic textiles, let us say synthetic polyester, and it can also do weight reduction, which can give silk like properties. All right. So, what do we do now? We will talk about low liquor application. Sometimes this is also known as minimum application processes, okay. Minimum application techniques. This is how also it is known. So, low liquor. What is this low liquor business? So, low liquor application actually means, for example, using less amount of water for application of chemicals. In the case of dyeing, you had talked about M to L ratio, right. So, if less is the liquor, better it is, we had understood. But in finishing, we generally do not use any exhaust process. Normally, we have a process of pat dry cure. So, what is the problem that we are talking about? In the context of textile processing, chemical processing, everyone talks about that the chemical processing industry uses large amount of water, starting from desizing onwards, just covering, whether it is mercerization, and you have bleaching, and you have dyeing, and now finishing, everywhere. You use lot of water, and because water requirement is very high, it is a water intensive industry, and similar when you wash, you have to dry. So, you use lot of energy to dry up the water, and so together these things, if you use more water, people do not like it today as an environmentalist. If you use more energy, you are creating some carbon footprints, people do not like it in any way. So, for it is for the benefit of everyone that if you could reduce the consumption of water, and maybe simultaneously you might have a reduction in the energy conservation as well. All right. So, if this is the problem of textile chemical processing industry, so today's discussion revolves around this. So, in general, this thing can be also related to what we call as energy management. Low liquor processes, if you use low liquor, energy is saved. Why? Because you may be drying it. If you have less water, you will dry less water. If you use more water, you will have to dry more water, for example. So, in the case of our finishing systems, we will talk about that low liquor. Other energy management in the finishing we can think about is theoretically in any of the chemical processing part of the industry, that every time we do drying, there is some hot air generated, hot flue generated, and which is exhausted out. Can something be done to that? Can sometimes we, let us say after dyeing, we wash off, remove the hot water bath, which is maybe at high temperature, let us say 90 degrees. So, other than the water which is being used more, the energy also is going out as a form of heat, right. So, recycling is one of the ways in which you do management of energy. It is always good, or at least extract the heat out of the outgoing gases or outgoing liquids. That also could be one of the part of the energy management system. The better managed industry would be obviously environmentally very friendly, possibly they will save money also. So, in the context of finishing, what do we do? Pad, dry, cure, something similar. So, finishing is the last process almost. So, in general we may not be washing the fabric quite a lot, but we have a padding, you have something called a expression, wet expression, and then chemical is there. So, application of all the finish and the chemicals is done by dissolving in water. That is one important thing. One can always have situations when you can do organic solvents to be used, can be used for application, but normally it is water which is being used. And what do we use? Mangles. That is our system, padding mangle. So, do you remember the definition of the wet expression? 100% expression means the weight of the fabric has increased 100%, 100% in the sense that 100 gram has become 200 gram, 1 kilo has become 2 kilo. So, 1 kilo liquor has been picked up, alright. That is what is the expression part of it. How much is the chemical in that solution? Maybe 2%, maybe 5%, that is what you require, maybe 3%, maybe half a percent, rest is water. So, what do you do with the water? Obviously, you have to evaporate the water, because you are interested in chemical, which is a softener or is a cross linking agent or the flame retardant and what have you. So, water has to be removed. So, whenever you remove water, you spend energy. So, energy, water are related, right. When we evaporate something, let us say water, we are talking about steam, all right. We are talking about steam. When you convert steam, the latent heat is very, very high. All right. And because of this, the consumption of the energy is high. So, our aim should be to use less water, so that you have to spend less energy in drying out. That is, let us say, the aim. So, such type of application systems and processes which will use less water, but do the same thing, will come in category of low liquor application techniques or minimum application techniques. You remember this? 2 ball padding mangle. What does it do? It does control the wet expression, amount of liquor and the chemical taken somewhere here after this squeezing. The squeezing occurs here. So, some of the excess liquor will come out, and what will go will be based on our wet expression. Sometimes also is known as wet pickup. Percentage. So, this 2 ball mangle is used to, there is a one dip. So, one dip and one nip, and you get control. So, uniform treatment and control of how much chemical and how much liquor is going. If let us say it is 100%, we are picking too much liquor. If you can reduce this pickup by 50%, well, how can you reduce this? You need the same chemical. You can increase the concentration of the chemical in the bath. So, at less expression also one can get the same amount of chemical on the textile, but water will be less. So, that is a simple common sense kind of environment. The other mangle that we know is called the 3-ball mangle, which we have seen. It got a 2 dip 2 nip situation, 1 dip here, second dip here, and 1 nip and the second nip. Okay. This is how this mangle, padding mangle works. Obviously, 3-ball mangle is used when the fabric got high GSM, thicker material. You are not very sure that 1 nip would be able to do the job. So, you got 2 dip 2 nip and you get a uniform treatment. At the end of this, you will measure your wet pickup. Okay. So, what are the limitations of a padding mangle? You say, well, I can decrease the wet expression, wet pickup, increase the concentration of the chemical, and so thereby actual water being picked up by the fabric could be less. So, how do you do? You increase the pressure, squeeze pressure. For 100% cotton based textiles, can increase pressure as much as you want, because the water is absorbed not just on the surface adsorbed, it is in the interstices of the yarn fabric, and some of it is almost chemically bound, which we call a hydrogen bond, hydrogen bonded water. It is very difficult to remove some of these water just by squeezing process, it does not get removed. So, if you squeeze too much, you actually may be damaging the fabric. So, almost you can think about 65%, if it is 100% cotton material, which is like a suiting material, it will be very difficult to reduce the wet pickup below 65% or so. You will be applying too much of pressure, it will not happen. That means that concept that I can make the pick up 50% does not happen in any of these mangles. So, there is a limitation. You want to reduce, but you cannot reduce, because if you keep increasing, you may be damaging the fabric by pressure, but water still will not be able to come out, because it is either chemically bound, which is hydrogen bonded, or it is too much in the interstices, in the capillaries, fine capillaries, then come out very easily, okay, which is on surface immediately comes out, but that is not enough. So, you may not be able to achieve very low pickup values by just increasing the squeeze pressure. That is not so good. So, some people then suggested, can we not do something where there is a nipping, but there is no dipping. So, you do not dip the fabric, but you may have some mechanism to pick up some liquid, limited amount of liquid, and then transfer onto the textile. So, textile is here moving in this direction, there will be nip here, and you can have an endless belt which can pick up some liquid. Let us say this is moving in this direction, this is moving in this direction, this is moving in this direction, okay. And so, it picks up some liquor, depending upon what type of material, what is the thickness, the amount of liquor can be controlled, and then it just transfers only whatever it has picked up. So, there can be some control based on the thickness of this so called endless belt, the material of this endless belt, and of course, the nip pressure that you will create. This can control. This way you can reduce the wet pickup to some extent. What are you talking about? What we are talking is, if the water has not been absorbed so much, then we do not have difficulty in removing it, because it has not been absorbed. But when you completely dip it, then it gets absorbed everywhere, it goes in the capillary, it goes into the chemically bound stuff. So, much before that happens, the fabric comes in contact with the liquor only at this point and gets out quickly. This is one way, a nice technique, which you can reduce the pickup, close to 10% reduction, not bad. If you can reduce pickup from, let us say, 65 to 55%, it is good. You are reducing some amount of water, and therefore, less water will have to be evaporated. You see, this 3-ball mangle, one can actually have very interesting possibility. See, what was the problem with the pad transfer is that, let us say you have applied a particular type of a chemical, this belt, so called belt, can get contaminated because it may absorb, because it must be a bit absorbing type material. So, some of the chemical will remain, and so if you want to add another chemical, different chemistry, then some contamination could be seen, which is one limitation which people may not like. Okay. So, but it is a good idea, if you are, let us say, not changing the chemical for a long period, then maybe you can think of washing it properly and then work it out. There is an interesting possibility with this 3-ball mangle. If you change the threading sequence in this system, let us say you have some more additional guides, 3-ball mangle, but using only one nip, all right, one dip, I am sorry, using one dip and approximately, shall we say, 2 nips, one dip, 2 nips and transfer. How do we do that? Transfer principle. Let us see. If we have a threading sequence like this, that there is a fabric roll somewhere here, and you are taking it out from here, and this gets nipped here and goes. It has no solution, it is not going into the solution, the threading sequence has been changed. So, it is going from here upwards, then goes all the way here, then all the way here, then gets a first nip. So, you get first dip, I am sorry, first dip. After this first dip, then it goes through this process where this roll is moving in this direction, this roll is moving in this direction, you can see the difference now, and this, after this dip, has now going to be nipped, and so additional, for example, liquor will fall here. Okay, is that right? Additional liquor will fall, and this wet fabric, with whatever expression that it has, is going to be taken out and taken in this way. So, what happens here? A completely dry fabric is coming in contact with a wet fabric, wet fabric. In the second nip, this first nip, squeeze. So, you do whatever wet expression that you can get. This wet fabric with whatever controlled wet expression which was there, whatever maximum was possible, you have done it, then comes in contact with a completely dry fabric, which also wants to absorb moisture or the chemical for that matter. That means some transfer will take place. So, now you have a third thing happening is transfer. If this happens, then what means? So, this pickup in this part which is going out will reduce further. It was some pickup here which was because of first squeeze, first nip. This will reduce further by doing this second nip, where a dry fabric is coming in contact with the wet fabric. Interesting. And what have we done? Just change the threading sequence, and you will suddenly find this also can reduce the wet pickup by almost 10 to 15%. Interesting, because there is additional material available for squeezing by capillary action, taking the material out, taking the liquor out from the wet fabric, the dry fabric will get partially wet. Now, it becomes partially wet. So, this fabric is partially wet here and this area is partially wet. Now, partially wet fabric, even if it is a thick fabric, now will enter into the pad bath and then go to the first nip, get squeezed, go to the second nip. So, where is the second nip? This is the second nip, and get out some reduction. Interesting, same machine can be used for reducing the wet pickup. Therefore, it is very interesting, not much expense to be done, but it will work. Will there be any contamination? There will be no contamination because there is no belt which is a constant belt. It is the same fabric going down and transferring. So, some transfer principle has been used, but same fabric onto the same fabric, same chemical which is required by the fresh fabric also. So, a bit of a jugglery here and there can also do some interesting reduction in the wet pickup. There is another important thing which was developed, which can absorb more moisture. That means, a fabric which has been nipped and got certain amount of liquor, can something more be taken out? That is what is there. So, in the pad transfer we try to apply less. In this 3-ball mangle system where we redirect the fabric from different ways, we are looking at the transfer, but removing the water more from the fabric, because the other fabric which were dry is also absorbent. This one also is something based on similar principle. Talking about the history, when we did not really have the modern looking mangles where you have the metal roll over which there is a rubber sleeve based on whatever hardness that you want. Before this type of a material was there, the people earlier used to do mangling on wooden rollers on which cotton fabric or was tightly wrapped around, and so it becomes, the surface became little cushy, and it could squeeze better without damaging the fabric, because if it is 100% wooden, some damage of the fabric could take place. So, just to dampen that effect, you had fabrics being wrapped on the wooden rollers, they became the balls, and then you go through the padding and squeezing process. The problem obviously you can understand, because of the fabric which has been wrapped on the ball will get contaminated with time, all right. And so slowly and slowly people change to the rubber sleeves, which are less absorptive, and so their purpose is to make sure that the contact is softer, pressure is enough, damage is less, and they do not get contaminated because they do not really absorb the chemical. So, you choose those rubbers which are not going to be, will be non-absorbing type, right. Now, this roboter-roller is combining the properties of these two things. That is a modern system which is rubber based, but maybe it is microporous, a rubber based system which does not interact with the chemicals that you use. So, you can completely remove them, there is no interaction, no damage, no contamination maybe, but is absorptive enough because maybe you have created pores on the surface. If there are pores, then the liquor can go into the pores also. So, this was an interesting concept from the historical perspective, where the so called sleeve made from the fabric which were wrapped was absorbing. You want to use that property without actually taking in the liquor permanently absorbed or chemical permanently absorbed, that it can come out, it does not interact. So, those two properties you want to combine. So, it may be something like this. So, you have the metal roll and you have a sleeve, okay, which is porous. So, designed very nicely, the pores are there, but it still has enough hardness to squeeze, enough resilience once it gets compressed, because whenever two such rolls will come in contact and press, so there will be some compression. So, once the pressure goes, it must be able to come out, it must be able to go back to its original position. So, this is an important thing. Now, this property has been utilized very nicely. How? So, normally you may have in a padding mangle one roll which is the normal roll, or sometime it could be a metallic roll also now, because the other one is softer, but it could be the normal sleeve roll also. So, this is this roll. Then you have this roboter roll, which has got a micro porous sleeve, which is as resilient, as non-reactive as the normal sleeves are. So, you have your bath, the fabric goes in, comes out, goes to nip, the so called excess liquor comes out, and the fabric goes finally for winding. Now, what is the difference between this and the previous one? So, first squeezing removes the excess liquor, which normally would happen in any of the nipping processes. Okay. But at the same time, what happens is, this microporous system has got air inside. Obviously, initially in the beginning it got air, all of them voids are filled by air. When it comes in the nipping area, this roll gets compressed. But natural, when it gets compressed, what will come out? The air will come out, because the pressure excess liquor which has been picked up by the fabric will come out. And what will happen? This fabric is taken all along the surface of this roll after nipping also. Nipping is over. Normally, if the nipping was over, the fabric would have gone straight somewhere else from here. Not this time. So, what you are saying is the fabric goes along this Roboter roll for some time. Here there was a compression, because the compression air had come out. But as I said, this sleeve, which is microporous sleeve, is also resilient. So, it expands immediately after the nip is over. After the nipping area, it expands. When it expands, so vacuum gets created in the pores because air had already gone out. So, how do you fill it? One, air can come back, sure. But if the wet fabric is in contact with the surface, as it is being filled, the liquid gets filled. Are you getting? The liquid gets filled in these pores. So, more liquor from the fabric which was nipped already goes into the porous portion of the Roboter roll. Clear? When the same thing now it is coming back, it has got water instead of air, it has got filled with liquor. So, when it comes here, it gets compressed. Liquor of this fabric as it is being picked up comes out. The liquor which was in the pores also comes out, like the air came out, because compressing. So, one liquor is in the pores which also comes out. The liquor which was being picked up by the fabric also comes out, and then as it goes out of the nip, it again sucks more liquor. So, this cycle continues. Is it a good thing or not? Yes, good invention, very good invention. So, advantage is very simple. You can get some 15, 17, 18% less pickup than the limit of the normal padding mangle, right. If it can go up to sometimes 50%, less than 50% also. For cotton I am talking about. If you talk about polyester, it will obviously be much less, because it absorbs less. There is no bound water in the polyester, it is only in the interstices and surface water, which is easy to remove. Alright, so that is the advantage. Less wet pickup means less energy to dry, direct benefit, as we understand. There is another technique which is called a spray technique. So, instead of taking through the liquor and removing, here there is a fabric which is moving, let us say in this direction. There is a bar, or let us say a pipe, which has got spray nozzles. Lot of spray nozzles, and you spray the chemical onto the textile. Textile is moving, the spray is falling on the textile along with water and the chemical, and so you can apply the chemical. What is important you can note from the previous ones, here there is no nipping, no nipping. Because there is no nip, You are independent, the fabric speed is independent. So, if you can move the fabric faster, if the nozzle are spraying the same amount of liquor per unit time and the fabric moves faster, the chemical or the liquor on the fabric will reduce. True or not? Good technique. So, the process is this. So, there are spray nozzles all over the place, the fabric moves like this and chemical is on the fabric. Interesting. So, this is the important concept here, that the speed of the fabric can be changed irrespective of the nozzle velocity, independent. In the previous case, because there was a nip, if you want to run the fabric fast, the nipping rollers also have to move fast. You can't, the surface speed of the fabric motion as also the rollers, nip, the balls, padding mangle balls cannot be different. Here there is nothing like that. So, you can actually theoretically reduce the pickup to whatever level you want. Let us say at an x speed of the fabric you are getting 100% expression. Increase the speed to 10x, it will become 1/10. No limits actually, whatever you want you can do that. It can be applied on both sides, interesting. If suppose you are applying very less amount of material on one side, say you want to give water repellent finish on one side, on the other side you want to give any other finish like a soft finish. Both of them can be given on two sides, of course based on the thickness of the fabric. You can apply the possibility. So, you can apply one thing on one side, the other thing on the other side. Interesting. So, spray. Another very interesting technique for minimum application is called the kiss roll technique, where there is no nip, but the transfer is taking place by kissing a transfer roller, which is highly polished metallic roller, highly polished metallic roller. So, it does not pick up too much liquor, because metallic roller it does not get contaminated, you can clean it up, you can change your dyes or you can change your finishing chemical at no time at all, you can just change them, clean them, start the next one, all right. So, what is the principle? The principle is that this is a highly polished roller, and so it picks up like a very small thin film of liquor along with it and contacts the surface of the fabric moving on the top. So, this is the fabric. Okay. And here this is the contact point. So, at this contact transfer takes place. How much transfer will take place depends on how much can be absorbed. At what speed this roll is rolling, at what speed the fabric is moving. There is no nip here. Is there a nip here? There is no nip. Because there is no nip, so you can move the fabric at a speed which is different than the surface speed of the kiss roll. So, because dust touches, therefore, name is kiss, it kisses and goes. So, if somebody asks this question, can the speed of the roll and that of the fabric be different? What do you say? Yes, they can be different. Here, can you apply the finish on the both sides? Think about it. Can you apply or not? You just have to worry about the threading sequence. You just make a right kind of threading sequence. You can apply finish on both sides. In case you want to apply two different types of finishers on two surfaces, this can also do the job. But at least what is happening? It gets absorbed on the surface, but because hydrophilic material, there are capillaries also, and so through the capillaries very quickly the chemical gets transferred to the other side. How much chemical can you apply? What could be the pickup limits here? No problem at all. Whatever limits that you want to reduce, move the fabric very fast or move the roller very slowly. You want to add more, you can move in the same direction, it will be there. If you move the opposite direction also, yes, there is some friction, but there is no nip, it just touches and goes. That is the only thing you do, right. Yes, the thread or the fabric line may not be just a horizontal line. You may have to guide the fabric, let us say by some guide roll, so that it may touch little bit and go. All right. So, this can be increased by guide rolls and so on and so forth, so that the length of contact could be changed. It should not be 0, it could be little more than 0. Just by little depressions of these guides, the fabric can then move whichever way you want to move, right. That is a kiss roll technique for you, very nice commercially available technique. Anyway, so as I said, limit of wet pickup is not there, you want 5% possible, only 5%. This machine is not limiting. There is another technique which is called the foam finishing. So, at the moment what are we doing? We take the chemical, dissolve in aqueous, make it an aqueous solution of that, dissolve in water, and then apply and want the water to come out. If suppose we say that this is not water, but what we have created is a foam. Foam means what? A large amount of air is in the bubbles. So, what is a foam? Liquid film. Within the film there is a lot of air. The size of the bubble obviously will decide how much air, how much liquor. So, if we blow more air, the volume can increase, okay, but the liquor will be very small. So, if suppose you apply this kind of a foam onto a textile surface, let us say this was my surface and I have applied foam, and this foam contains 80% or more air. So, as the liquor gets absorbed, or you can put some roller here, it will break, foam will break, liquor will go, air will go where? Air will go out. So, liquor will be very less. So, there is something called a blow ratio. So, let us say you have certain amount of liquor, you make a foam of this and the volume increases, this is 2 times, the volume is 3 times, the volume is 4 times, the volume is 5 times. If the volume of this liquor becomes 5 times as foam, because you are foaming, right, you are not doing anything, just foaming. Like for example, if a soap solution, you just keep churning it quite a lot and also push air inside, you will see suddenly the volume rising, right. But what is rising mainly? Not the chemical is not increasing, the water is not increasing, air is getting inside, so volume is increased. So, if it becomes 5 times, you say blow ratio is 5. Let us say I have done a blow ratio of 5 type of foam with some chemical and now I apply, because you have you seen the foam It's almost like a semi-solid kind of environment, which can, based on what kind of foam, it can stay like a, it can have its own structure, you know, all the cells sitting over each other. They do not flow just like a normal liquid. A foam can stay in your hand for a good amount of time, right. It has got liquor only in the film, air is there inside. So, you apply. What is the advantage? Application can be uniform because the volume is large. If volume is very small, like if you say, well, I will take only 20% of chemical, I will put it and I will take 10 ml of thing and I want to spread 10 ml. Difficult to spread 10 ml uniformly. It may get absorbed more somewhere and you don't have way to make sure that it goes the other side. But if you have large volume, then you can easily apply. Errors are less. Uniform application. At the end of the day, everything goes in the air. Very little amount of liquor remains on the fabric. So, how do we generate foam? Very simple. You have liquor, so you will have something called a stirrer. You would have some way to blow air. So, you blow air and keep stirring, whatever RPM, and suddenly you will see if supported correctly, because you may have to add another agent called a foaming agent, which is like you can say our simple soap, which we also call surface active agents. So, we can add some of them. You may have to add some polymeric compound to make sure the film is more stable and does not break very easily, and etcetera, etcetera. All those things can be done, but if you do these two things, the volume will keep rising. You go up to the whatever desired blow ratio and apply. If you have lot of foam, you apply. How do we apply? Well, we know this technique, application technique, coating technique, knife on air. So, the fabric goes like this, the foam is here, and based on the gap that you leave, the foam will be coated, and then you can break the foam after some time and do drying, curing, whatever you want to do. But imagine you have reduced the water, interesting. Similarly, knife on roll can be used as a coating technique. So, you make a foam and coat. There is another process which is commercially viable process, where you do not make a stable foam, keep it somewhere, take it out, then apply. You continuously keep generating the foam and continuously keep transferring the foam and then apply onto the textile. For example, here the generated foam is entering here. This is the foam, the hollow system through which it moves, and so this is the transfer area. Okay, this is the transfer area. So, the foam enters here, the pressure gets equalized as it moves. As it moves along this, pressure gets equalized, and this is the application point. So, there is a foam generator somewhere which is transporting the foam through this, and in this chamber it goes all along the chamber. Okay, it goes all along the chamber, and during this motion the pressure gets equalized. So, continuous formation of generation of foam, continuous application of foam. right. So, liquor enters from there, air enters from somewhere else, the foam is generated in a turbulent environment and it is pushed into the system, and around the application area it comes. This kind of a area where it is moving all along, in some chamber the pressure is getting equalized. This is for control purposes, and then the fabric is moving at a particular speed, the foam is being applied at a certain speed. So, you can control your wet pickup as much as there is no nip here also. If there is no nip, then what happens? Speed of the fabric could be different, the application volume of the foam could be different. So, there is no problem of what level of wet pickup you want, how much low wet pickup you want, there is no problem at all. Can it be applied on both sides? If you want, because you get low pickup, it is quite possible that the liquor is so low, it does not migrate to the other side. You can have so much low, then you can apply on the both sides. Sure, you can apply on both sides. Okay. One type of finish on one side, other type of finish on the other side. So, this is called the foam finishing technology, FFT, foam finishing technology. You can appreciate now the low liquor and therefore less amount of water evaporation. The question that sometimes people may ask, how low should be the wet pickup? Now, some of these techniques can give you very, very low. You want 2%, it will give you 2% pickup. If suppose I want to do a wash and wear treatment, if I do 5% pickup on a cotton, will you be satisfied? I can change the concentration, that is not a problem. But what you will find is, if you apply from one side and expect the other side to get uniformly in a uniform application, it may not happen. It may not happen. So, if you want a uniform treatment, a bulk type of finish, not a surface type of finish, a bulk type of finish and a uniform treatment, although your technology of application allows you to reduce the wet pickup to as much as you want, but people say it will be bad for you. If you want uniform application for a bulk treatment like wash and wear, flame retardancy, and you want to use these technologies, then minimum pickup should be, particularly on cotton based systems, hydrophilic, not less than 30-35%. So, that is because you want uniform application. If you become less than that, then it may not be uniformly applied on both sides and into the fibers within the molecular systems. And so, that may be the limitation, not the machine, right. So, what have we learned? So, we have learned that wet processing industry is energy intensive. It consumes more water, it consumes therefore more energy to drying for drying purposes. Therefore, we have low liquor techniques, sometimes also known as minimum application techniques. So, we know why they are useful, because less water means less water to be evaporated, that means less energy to be consumed. So, that is what it is from the energy management point of view. In the next class, we will see some of the ways in which we can recover the waste heat, the heat which has been going, which is going out with the exhaust, which is going out with the hot liquor. Can something be done, recovered? Why should we not recover? We will talk about it in the next class. Till then, all the best, enjoy, see you.